Welcome to Math with Mr. J.
In this video, I'm going to cover how to add, subtract, multiply, and divide mixed numbers. Now, I'll go through one example each, which should be helpful for anyone looking for a quick review or refresher, whether you learned this recently or years ago. If you need more help or examples, I dropped links to other videos on mixed numbers down in the description. Now we're going to start with addition. Let's jump into our example where we have 5 and 2/7 plus 4 and 2/3. Now the first thing that I'm going to do, I'm going to rewrite this problem vertically, so up and down, lining up the fractions and whole numbers. So we'll start with 5 and 2/7 plus 4 and 2/3. So once we do that, we need to find a common denominator. We're not able to add because we have a 7 and a 3 for our denominators. We need a common denominator in order to add the fractional part of these mixed numbers. So in order to find a common denominator, we need to find a least common multiple, and that's going to be our least common denominator. Now you may be able to figure out what the least common multiple between 7 and 3 is without writing out the multiples. But as a review, I'm going to come to the side here and we'll write out our multiples, and I'll show you how to find the least common multiple. And again, that's going to be our least common denominator. So let's start with 7, and I'm going to write out the first 4 multiples of 7. Now, the multiples go on forever, so my suggestion, write 4 or 5. See if you have any in common. If not, you can always extend your lists. So 7, 14, 21, 28. Now we'll write the first 4 multiples of 3. So 3, 6, 9, 12. And we don't have any matches there. We don't have anything in common. So let's extend our lists. Now 7, we're already at 28. And for our multiples of 3, we're only at 12. So let's extend that list. So then we have 15, 18, still nothing in common. And then we have 21. So 21 is going to be our least common multiple, and therefore our least common denominator. So that's what we're going to use. So once we have that common denominator, we're going to rename the fractional part of our mixed numbers with that common denominator. That way we'll be able to add. So let's go over to our mixed numbers here and rename. We do not need to do anything with the whole numbers. So this is going to be 21. So let's use equivalent fractions to rename that 2/7 with a denominator of 21. So we need to think, how do we get 7 to equal 21? Well, 7 times 3 is 21. Whatever we do to the bottom, we must do to the top in order to keep this equivalent. 2 times 3 is 6. So 6/21 is equivalent to 2/7. We're not changing the value of the problem at all. These are equivalent fractions. We're just renaming using that common denominator. Let's bring the addition sign over, and then we need to do 4 and 2/3. Again, we do not need to do anything with the whole number, and we have a common denominator of 21. So let's think, how do we get 3 to equal 21? Well, 3 times 7 is 21. Whatever we do to the bottom, we must do to the top in order to keep this equivalent. So 2 times 7 is 14. So now we're ready to add. To recap, we found our common denominator of 21. Then we renamed the fractions of our mixed numbers using that common denominator of 21. Now that we have a common denominator between our fractions, we're able to add. So let's add our fractions and then whole numbers. So for our fractions, add the numerators. 6 plus 14 is 20. And then we keep our denominator of 21. So 6/21 plus 14/21 equals 20/21. So we added our fractions. Now let's add the whole numbers. So 5 plus 4 is 9. So our final answer is 9 and 20/21. Always check to see if you can simplify the fractional part of a mixed number. Well, 20/21 is in simplest form. The only common factor between 20 and 21 is 1. So we are done. And our final answer is 9 and 20/21. Next, let's move on to subtraction. So for our subtraction example, we have 9 and 3/4 minus 2 and 2/8. Now the first thing that I'm going to do is rewrite this problem vertically, so up and down. And I'm going to line up my whole numbers and fractions. So let's come to the side here and we'll do 9 and 3/4 minus 2 and 2/8. So what I'm going to do, I'm going to subtract the fractions first and then the whole numbers. Now when we subtract fractions, we need a common denominator. So as we have the problem written out now, we have a denominator of 4 and a denominator of 8. So we can't subtract quite yet. We need to find a common denominator and rename. We find a common denominator by looking for common multiples, and then the least common multiple we can use for our least common denominator. So let's write out our multiples of 4 and 8. Now you may be able to do this, figure out what the least common multiple is without writing out the multiples, but I'll write them out as a review. So the multiples of 4, well, let's count up by 4, 4, 8, 12, 16. Now those multiples go on forever. So my suggestion, write out 4 or 5. See if you have any in common. If not, you can always extend your lists. Now let's write out 4 multiples of 8. So we have 8, 16, 24, 32. Once we have that, we can look for the least common multiple, which is going to be the smallest number in value that they share, which is going to be 8. So 8 is going to be our least common denominator. Now that we have the common denominator that we're going to use, we can rename the fractional part of these mixed numbers with that common denominator of 8. So let's start with 9 and 3/4. So this equals, keep our whole number the same, and then we need that common denominator of 8. So let's use equivalent fractions here. 4 times 2 equals 8. Now whatever we do to the bottom, we must do to the top in order to keep this equivalent. So 3 times 2 gives us 6. 6/8 is equivalent to 3/4. We're not changing the value of the problem at all. We're just using equivalent fractions to rename that fraction with our common denominator. So let's do 2 and 2/8 now. We'll put our subtraction sign there. Now 2 and 2/8, that already has a denominator of 8. So we do not need to do anything with that mixed number, and specifically the fraction. Again, because we already have that denominator of 8. Now that we renamed what we needed to rename, we have a common denominator of 8, and we're able to subtract. So let's subtract the fractions of these mixed numbers. So 6/8 minus 2/8. Subtract the numerators, 6 minus 2. That gives us 4. And then we keep our common denominator of 8. Once we have that, we can subtract the whole numbers. So 9 minus 2 gives us 7. So we get 7 and 4/8. Always look to see if you can simplify the fractional part of a mixed number. We can. 4/8 can be simplified. We have a greatest common factor of 4. So let's divide both of these by 4. And we get 7. 4 divided by 4 is 1. 8 divided by 4 is 2. So we get a simplified answer of 7 and a half. So we've gone through an addition and a subtraction example. Now we'll move on to multiplication. For our multiplication example, we have 4 1/2 times 2 3/5. Now the first thing that we want to do is to convert our mixed numbers to improper fractions. That way we have a numerator and a denominator, and we can multiply straight across. So in order to do this, we start at the bottom. So let's start at the bottom here, and we work our way to the top. We multiply, then add. So we do 2 times 4, our denominator times the whole number. So 2 times 4 is 8 plus our numerator of 1. That gives us 9. So again, 2 times 4 is 8 plus 1 gives us 9. That's the numerator of our improper fraction. We keep our denominator of 2 the same. Now that improper fraction is equivalent to our mixed number. They're just in different forms. We're not changing the value of the problem at all when we convert to an improper fraction. Let's bring our multiplication sign down and then convert our other mixed number. So we multiply, then add. So 5 times 2 is 10, plus 3 gives us 13. That's our numerator. And then keep our denominator of 5 the same. Once we have our mixed numbers converted to improper fractions, we can multiply straight across. So numerator times numerator and denominator times denominator. Let's start with the numerators. So 9 times 13, that gives us 117. And then 2 times 5 gives us 10. So that's our answer as an improper fraction, 117 tenths. Now let's convert that to a mixed number. We do that by dividing our numerator, 117, by 10. Now we can either do this using mental math or writing out the division problem to the side. I'll do both here. So 117 divided by 10, how many whole groups of 10 can we pull out of 117? Well, 11. That gets us to 110. We don't hit 117 exactly, so we have something left over, a remainder. So the difference between 110 and 117 is 7. That's what's left over. That's our numerator. And then keep our denominator of 10 the same. Now, if you're unable to do that using mental math, you can always come to the side and write out the division problem. So for example, we'll start with how many whole groups of 10 out of 11? 1. 1 times 10 is 10. Subtract, we get 1. Bring down the 7. So how many whole groups of 10 out of 17? 1. 1 times 10 is 10. Subtract, and we get a remainder of 7. So we get the same thing either way. Sometimes problems are a little more friendly and we can do them using mental math. Sometimes we may need to write out the division problem. Either way works. So just to recap how we converted from an improper fraction to that mixed number, we did 117, the numerator, divided by 10, the denominator. So how many whole groups of 10 out of 117? 11. Then we have a remainder of 7, which is our numerator, and we keep our denominator of 10 the same. Always check to see if you can simplify the fractional part of a mixed number. Well, 7/10 is in simplest form. The only common factor between 7 and 10 is 1. So this is in simplest form, and we are done. 11 and 7/10. Lastly, let's move on to division. So for our division example, we have 4 3/4 divided by 2 1/3. Now the first thing that we want to do is to convert these mixed numbers to improper fractions. That way we just have a numerator and a denominator. Let's start with 4 3/4. And we start at the bottom and work our way to the top. So we multiply, then add. So we do 4 times 4, so the denominator times the whole number. 4 times 4 is 16. Then we add the numerator. 16 plus 3 is 19. So 19 is the numerator of our improper fraction. We keep our denominator of 4 the same. Then we can bring our division sign down and convert our second mixed number. So again, we multiply, then add. So 3 times 2 is 6, plus 1 is 7. That's our numerator, and then keep the denominator of 3 the same, so 7/3. 19/4 is equivalent to 4 3/4, and then 7/3 is equivalent to 2 1/3. So we're not changing the value of the problem at all when we convert to improper fractions. Mixed numbers and improper fractions are equivalent, they're just in different forms. Now again, we're converting to improper fractions, so we just have a numerator and a denominator, and then we can go through our steps for dividing these fractions, which we're going to use keep, switch, flip, also known as keep, change, flip. So no matter how you think of it, they mean the same thing. I know there's different words out there for these steps, but in the end, they all mean the same thing. So let's keep our first fraction here, our first improper fraction, so 19/4. Then we switch or change our division to multiplication, and then we flip our second fraction, our second improper fraction here. So the denominator becomes the numerator, and the numerator becomes the denominator. This is called the reciprocal. So we have 3/7. Once we get to this point, we can multiply straight across. So numerator times numerator, and then denominator times denominator. Let's do the numerators first. So 19 times 3, that gives us 57. And then we have 4 times 7, which is 28. Now that's our answer as an improper fraction. We're going to convert it to a mixed number. So we need to do our numerator, 57, divided by our denominator, 28. Now we can do this using mental math, or we can write everything out. Some problems are going to be a little simpler and we're going to be able to use mental math, and in some situations we'll have to write out the problem. I'll go through both here so you can see what that looks like. Let's use mental math here first. So how many whole groups of 28 out of 57? Well, if you're able to think about that, it's going to be 2 whole groups of 28 because that gets us to 56. So 2 whole groups of 28. Now we do not hit 57 exactly. We have something left over, a remainder. So the difference between 57 and 56 is 1. So we have a remainder of 1. And we keep our denominator of 28 the same. Let me write that out as well. So we have 57 divided by 28. So we need to think how many whole groups of 28 out of 57. Well, we said that's 2. That gets us to 56. So 2. 2 times 28 is 56. So we get a remainder of 1. This 2 is going to be the whole number, part of our mixed number, 2 whole 28s out of 57. And then this 1, the remainder, is going to be the numerator. And then we keep our denominator of 28 the same. Once we get to our mixed number, we can check to see if we can simplify the fractional part. 1/28 is in simplest form. The only common factor between 1 and 28 is 1. So we are done. 2 and 1/28. So there you have it. There's a review of how to add, subtract, multiply, and divide mixed numbers. I hope that helped. Thanks so much for watching. Until next time, peace.